I can build an equation for a linear function by using its rate of change and initial value. First off, right now, if you can't find the rate of change, if you can't find the initial value, you need to go back and review some earlier lessons or seek help right now. Otherwise, you will not be able to understand how to get those. This lesson is not about finding the rate of change. It's not about finding the initial value. It's about taking those two parts of an equation, or excuse me, the parts of the function, and building the function's equation, or the function rule, if you were. So let's get started. First off, find the rate of change in the initial value. That's why you need those skills, and then we're going to place them in there. The rate of change is usually going to be multiplying the x value, or the input value, and the initial value is usually going to be standing alone. It's going to be joined by addition or subtraction almost every single time for these basic linear functions. So I'm watching the Final Four tonight. Let's just say Kentucky had scored 30 points already, and then they averaged 2 points a minute to finish the game. So my initial value is 30 points. My rate of change is 2 points per minute. Let's see if we can find an equation here. Y is going to be my output. So with all of these equations, start with y equals. My rate of change is 2. So normally we would just say 2 or times it by our input variable. In this case it's x, so 2 times x. And what's going on with our initial value? Well, that's 30. It's going to be joined either by subtraction or addition. Are we going to build on this 30 points, or are we going to take away from the 30 points? If we're building to it, we need to add it. If we were taking away, we would subtract. That's it. The equation is built. So after 1 minute, how many points does Kentucky have? X would be 1 minute. 1 times 2 is 2. 2 plus 30 is 32. So my new output would be 32. If we wanted to say, well, how many points would Kentucky have to finish the game? If there was 20 minutes left, I would input 20 minutes. And this would be able to simplify down to 70. The new output would be 70 points. That's how these equations work. It's very similar to filling out the function tables. So here we go. Toby earned $40 an hour and already made $200 today. Y equals my rate of change times x. That's my input in this case. It will be the number of hours that Toby works, and it's going to add onto the $200 he already had. So y equals 40x plus 200. If we're looking at a input-output table, please understand you are going to have to go find the initial value and the rate of change. In this case, I've already worked it out for you. The initial value would be 0, and that is money, and the rate of change would be $10 per cell. So y equals 10x. I can put plus 0 if I want. Let me see if I can clean that up for us a bit. I can put plus 0, but it's really not needed. It's just understood nothing was there. So here we go. Y equals 10x. I can put plus 0, or I can just say y equals 10x. Here, you'd have to read the graph. You'd have to understand that your initial value is 1 ounce, and that for every increase in x, it goes up 1. So the rate of change in this case would be 1 over 3, or it'd be 1/3, 1 ounce for 3 minutes. So that's my rate of change. I'm going to be adding on to the ounce, and so y equals 1/3 x plus 1. The true rate of change is actually 0.3 repeating, and that would be another way of writing it, because 1/3 is the same as 0.3333. What if debt's involved? Again, this is just where you have to take a look at the situation for every scenario that you look at. Usually you would put the initial value first, and then you would subtract the rate of change from it. It depends. If the debt is shown as a negative value, then that could change some things. For these simple initial problems, just to get your feet wet with it, normally the amount of money borrowed is going to be a positive amount. So let's just say that X is going to be the amount of money owed, and Y is going to be the number of weeks that comes by. So at 0 weeks, Tammy is going to owe $400. After 1 week, she's made a $40 payment, so now her new amount that she owes is $360, and you'll see that sets off a chain of events where it goes down $40 every single week. So then it goes to $320, $280, and $240. So let's try this. Here's the $400 she owed, that she borrowed, and we're going to subtract $40 every week. So it'd be 400 minus 40x. That was a little hard to work with tonight here. There we go, 400 minus 40x. And there's your equation. Now, let's say that you built your equation, you try to find the answer on a multiple choice quiz or test, and you can't find it. We'll try this. Here's our equation. Let's flip our initial value and our rate of change. So y equals, our rate of change was 40x. What's in front of it? A minus sign. So let's just move the minus sign with it. And was this a positive or negative 400? Well, it's positive. What we did here is we took this initial equation that we made, and we made an equivalent equation just by moving the pieces of it around. It would still get us the same values. It works if I plugged in 1 for x. 1 times negative 40 is negative 40. Negative 40 plus 400 is 360. And after 1 week, well, hey, that's the same thing that we had on our table. After 2 weeks, that'd be negative 80 added to 400, so that'd give us 320. It's an equivalent equation because it gets us the same answers that we were needing. So that may help you be able to find the equation that's there, unless it's just a tricky situation that doesn't follow these normal rules. That would almost always work in helping you get to what you need. The equation building is not too hard. Just remember the rate of change is always going to have the x beside it. If it's a situation where you need to multiply it, and then you're adding or subtracting the initial value.